Come back to my YouTube channel. We're still under strength of material N6. We'll be looking at combined direct and bending stress. All right, so may you want that, let's say you have given a bar like this. Let me just say use the square bar. We have the bar like that. All right, let's say you've given the square bar like this. What can cause this bar to bend? What is the force that will cause the bar to bend? Or we can say just the resultant stress that will cause this bar to bend. Right. So this bar can either bend in the y-axis or in the x-axis. Let me just draw a Cartesian. From mathematics, you know this is an x-axis like this. This is what it's an y-axis. These bars can either bend in the x-axis when it's bending like this, it's bending like in the x-axis, or can either bend in the y-axis. What I'm trying to say about that, let me explain here. All right, we are given, I will separate it like this so that you'll understand. This is an x-axis, this is an y-axis, right? So let me just say now, I applied a force there. I will indicate the dot here. I apply the force there. You see, that force I applied where? On the y-axis of this bar. On the y-axis of what? Of this bar. So if I apply the force on the y-axis, the bar where it will bend, if you apply it here on the top, you apply it on the top and on the y-axis, right? You apply the force. Let me just draw the y-axis, the Cartesian. We have y-axis and x-axis. I applied a force. I'm just taking that. I applied the force there on the axis, on the y-axis, and on the top, like on the top part. I'm talking like on the top part, like this. And I want you to understand something. This bar will bend in the x-axis, but will bend what? Downwards when you apply the force upwards. Let me illustrate this. It will result, you'll have the bar, that force that will apply, it will cause this bar to bend in the x-axis. The bar will bend in the x-axis. Are we together? The bar will bend where? In the x-axis. It will cause this bar to bend along the x-axis. The bar will bend like up downwards. You see, will bend like this. Let me just use a curve. The bar will bend like this. Will bend where? In the x-axis. Let me draw. The bar will bend like this. It's bending where? In the x-axis. Will bend on the x-axis. When you're applying where? The force on the y-axis. If you apply the force on the y-axis, on the top, the bar will bend downwards in the x-axis. Are you together? When you apply the force, and then what is this force that you've applied? We call this force alone. The one you see the arrow is pointing there. That force, you call it what? The compression, the compressive force, right? It's a direct stress. We call it the direct force, but will be with that one there it's acting. We call that this one will be due to what? To the direct stress. We call it the direct stress, the one that is applied here. This one is what? It's a direct will cause the direct stress when this force that we apply on this section, right? This force here we apply there on the certain distance, it will cause this bar to bend in the x-axis. All right, then we must know the distance between this point. What is the distance that will cause this bar to bend? We call it a centric force. What I'm trying to say about a centric force, let me draw you a front view face if you can check like this, can give you a front view face. This is the same thing. I'm just throwing what the front view face. If I'm drawing the front view face here, we'll have our y-axis and then we'll have our x-axis. Right, I'm giving you what the front view face. As you can see here, now we are applying the force here on the top of the bar. Right, we're applying it there. So the distance between, since you're applying on the top, the distance from there going downwards, this distance like this, that will cause the bar to bend where in the x-axis. We call it, will have the distance E. We call it eccentric force. It's the force that causes the bar to bend. In a lot of the textbook is denoted by E. It causes the bar to bend. It's a certain distance that should be applied so that the bar will bend. We call that eccentric force. If we don't have eccentric force, eccentric distance, that bar, it won't bend, will be compressive. Let's say example, you have the bar like this. If you have the bar like this, and then you apply the force direct in the center, you apply the force there, it will compress. You call that compressive. It will make the bar to reduce in size. If you have the bar, the big bar, if you it will compress, will become short because you apply it in the center. The eccentric force, remember, is the distance from the center of the bar, going upwards or going in the horizontal, depends where. If you're applying it on the y-axis, you see, so we apply it here on the y-axis, this will take place. If you apply it somewhere, let's say you have the bar like this, if you apply the eccentric force, if you apply the force here on the x-axis, here it's a force, you apply it there, the distance will be between where will be this, your eccentric force will be on the horizontal part because you apply it where on the x-axis. That is what will be the eccentric force. We'll discuss about that. So that distance, you call it the eccentric force. So the bar will bend where on the, as you can see, on the what, on the x-axis, here on the x-axis, the bar will bend there on the x-axis. The bar will bend where? On the x-axis. This is an x-axis. As you can see, there's a bend. There's a bend. You see the bar will bend. All right. So we must know that that bar will bend. So when it's bent, I want you to understand something. If you have this bar, you see the portion that I will highlight. This portion here that I'm highlighting with the red, the downwards. You see this one. We'll call that what will be the tensile, will be what will be the tensile bending moment. That will be what the tensile bending moment. Our bending moment there will be what will be tensile. Whereby tensile is what is positive. Here where you experience the bend, where it's curved, where it's bending like that, here on the top, this part we'll call them will be what our bending stress. This is the bending stress, by the way. The bending stress here will be compressive. Will be compressive. Let us practice more of this so that you'll understand what I'm trying to say. Let me just do the shape like this. If the bar bends like that, in this form, if your bar bends in this format, I want you to show, let's say again, the bar bends in this form. If the bar bend in this format, I want you to note something. Our bar, I have option 1 here, 2, we have also 3. The bar here bends in this manner. I want you to identify something. Number 4, it bends in the opposite. your bar. This is simply just your bar. So when we identify now the bending stress, the bending stress in this portion like this, like you see the one that I'm showing, the one there, that side, this will be what? Our bending stress here will be what? Will be tensile. Will be tensile. That means you'll take it as positive. But here on the top part, here, where the bar is bending on, this is when it here will experience this what? The bending stress here will be what? Compressive. Will be compressive. Will is a compressive one. Let's analyze the second one so that you understand. Here you see this part like this. This is like a cup like that. So this one will be what? The bending stress here will be compressive. Will be compressive. Then the bending stress here in this portion from there going in that side, in this side, there will be what? The bending stress here will be tensile. Our bending stress here is simply tensile. I will just say T will be tensile. Coming this side here, this bending stress here will be what? Compressive. I'll write it as C. I will write it, no, I won't write the full name. Then this side, the bending in this side, we call that bending. The bending stress here will be what? Tensile. This side, the bending stress is what? Is compressive. Then this side, the bending stress here, it's what? It's compressive. The bending stress on this side, it's what? It's tensile. Okay, sorry, it's tensile. Here, you understand? You see what is going on? You must able to differentiate when your bending stress, it is compressive or it is tensile. Why are we talking about compressive and tensile? All right. This bending stress is calculated by, the bending stress is given by the bending moment. This is a bending moment. It's not the same thing. This is a bending stress, but this is a bending what? Moment. The bending moment. Multiply by y, the centroid. It's simply just the centroid. The half of the centroid. Right? Divide by, remember, it depends. Depend by, you will, this is a second, will depend by, or will divide this by second moment of inertia. Depends. It will depend where the bar is bending. Right? It will depend. But the bending moment, the bending moment will be what? Is force multiplied by the distance that will cause the bar to bend. We call that it's eccentric. That distance is what? It's an eccentric distance. It always will be eccentric distance. Right? It is going to be what? Eccentric distance. So that is bending moment. So the bending stress is simply what? You can substitute this here if you want back. It's force multiplied by eccentric distance multiplied by y divided by second moment of inertia, or the moment of inertia. Do you call this the bending? This is what? It's a bending stress. It's only this bending stress. Right? Now the combination of the direct, remember this is simply that, is simply just the, it is a bending. But now the bar, we have talked about this bar. Since we have this bending, remember this is the thing that happened on the sides. But also remember, we said here we'll have what? The direct force. The force that is acting there. It's a direct force. That is direct. Remember now, when we'll be looking where at this front view now. The force that is acting there at the eccentric. Now this is a direct, it's not bending, it's not a bending. It's acting here at the section, at the section. Right, this is a direct. While we'll experience our bending, while here we'll experience our bending like this. It's when here, while these portions will experience what? The, as you can see, while this parts, it's a bending what? Bending stress. It's a bending stress. whereby we know that is compressive. Then this side will be what? Like this, it's a bending stress, will cause the bending stress whereby it is tensile. But this force, because it's taking place, there's applying there, that is a direct. The direct, check that direct because it's acting towards. If you have something like this, remember the direct that is acting, that is pointing onwards. This is what? It's a compressive. But now it's a direct. It's not just there. It's a direct. The direct stress, that will be direct. Let me just say D, direct. Direct is what is force divided by area. We know that. From where? Remember, from your N5, if you have a bar like this, if you are given the bar, all right, if you have given the bar, and then this bar, let me do like this, and then this bar experience the force that is acting also this side. Let's say, let me just say 100 Newton, then the width here, let's say, is 2, then the height is 3. How do we calculate the stress? This is a direct. The direct stress, you're going to say force divided by air, whereby you're going to take the force, whereby that's 100 divided by the area there, since it's a square, is 3 times 2, whereby we say 3, 2, or can say 3 times 2, right? That is how you're going to calculate what the direct stress of what. But this type of direct, what is the type of this direct? It's a direct, yes, it's a direct, but what is the type of this direct? It is compressive. Then we have what we call the tensile stress, the direct, the tensile one. Let's say we have the bar. This is the pulling one. Let's say we have the arrow is pointing in that direction. Is the pulling. You will have the force that is taking the place in the bar. Let's say you have a bar or the section. Doesn't matter whether it's the bar or it's what. But I'll just make an example with the bar like that. Or isn't it? So you have the pulling forces here, 100 Newton. So this is direct. It's acting on the cross section, isn't it? That is a direct. That is the direct stress. We call this direct stress. But this direct stress is it's force divided by what? By area. But this, because it's acting there, we can call this will be what? Will be the tensile. It's a tensile one. Tensile, and then it's what is associated. Tensile will be positive. Take it as positive, please. And then compressive, take it as what? As negative. Always take it as negative. So we have two things here. As I've said, here we'll have what? The direct stress plus, that is why we say combine, that is why I call this topic a combined direct and bending. Yeah, right. And bending moment there, or bending stress. You can see that, or bending stress. You understand what is going on there. So you see we have the bending, at the same time we have the force, we have the what this we call, we have that force which is direct there. Are we together? That is what we have there. It's a combined direct and bending stress. The topic of this, it's a combined direct and bending stress. That is how we call this now, because we have the force that is acting on the cross section, right? The force that is acting on the cross section, isn't it? Plus here, this bar, it's bending in this side and that side. So we have two things. We have bending stress, and we call them combined direct stress and bending stress. So how can you combine this? When you combine this now, you're looking where? Remember, the bending stress is that. So we will have what we call the resultant. Since now it's what? When we combine these two, we'll obtain what we call the resultant. Whereby that resultant will be direct force, direct stress. I mean, it will be direct stress. It's a direct stress. You add plus what? The bending stress. It's a combination plus the bending stress. So this is what we have there. You'll have this. But what is the... So how can we tell that our resultant is going to be... How can we tell it's going to be a compressive or it's going to be tensile? If you obtain the answer is positive, it's going to be tensile. If you obtain your resultant as negative, will be going to be compressive, the type of nature, the nature of the stress, the nature of the stress. Then is are we together then? Are we together? So that is what we have. So we know now the resultant stress is simply what? Direct. It's a direct is what is given by force divided by area you've seen. But now plus what? The bending stress. Or let me first using this, I can say B. Let me just say D. D stand for direct, plus then B stand for bending stress. So the direct stress is given by force divided by area. And then obvious is just the formula. Here I'll just say, let me just say plus or minus for now. It can be plus or minus for argument's sake. So here we have, even if I don't write that plus or minus, the nature will tell us. Let me just say plus or minus will depend here whether our bending stress, the one that we'll use here, it's a would depend when we are using the compressive or the tensile. Okay, it's fine. Plus or minus what? The bending stress. So this will be plus or minus. The bending stress is given by what? By this formula, which is F multiplied by eccentric distance divided by Y divided by I. All right, so this is what we have. This is our resultant. All right, this is our resultant. Are we together? That is what we have. All right, so we have what we call them. That is what we have, guys. This is what we have. This is what we have. Is given by this, by that formula. Is in Are we together? So we know how to calculate the area, the force, if it's going to be given, maybe might be given. So take note. So we've given that. All right. So we're given this. This is the formula to calculate the resultant stress. All right. Now between these two, you must understand what is going on. What is that? What is Y? Let me explain this Y first before, because it won't always be Y. It can be X there. Okay, let me just explain. Let's say you have here, it's a face. I'm doing like this, the square. The distance from there, I will just say it's a depth. I'll just say this is a depth from there until there. This is a depth. Then from here and there, this is base. We know that it's a base. It's a base. So how do you find the Y? Remember here we'll have this, and let me just say and cut this. This will be our center, whereby it's the x-axis, x face. Here we'll have our y face, y. This will be y, x. We know that. So the distance y is from the center going downwards from the bottom until the center. You see, that means y will be called to what? The depth. D divided by what? By 2. That is our y. Are we together? We'll use it when your bar is bending in the x-axis. If your bar is bending along the x-axis. If your bar is bending along the x-axis. Are we together? Then what about if your bar is bending along what? The x-axis. If it's bending like this or like that, is bending along the x-axis. The x-axis. As long as it's bending along the x-axis. So we'll have y is equals to that. Alright. Will be like that. Then since it's bending about x-axis, what about I? Since it's bending about x-axis, the x-axis x part, so our moment of inertia will be I x x. This says now you are bending along x-axis, it will be I x x. And then second moment of inertia, I x x, if you have given this bar, will be what? Will be b, will given by b, the depth is cubed divided by 12. This is how you determine the second moment of inertia there along what? The x-axis. When you're taking that in the x-axis, this is what you will have. This is what you'll have. This is what you'll have. All right. Now let me say we have given here, it's a bar. You'll be given the front view, but you can write it to be isometric if you don't understand. You'll be given something like this. Let's say now you have something like this here. I want you to check. We have x, we know. Here we'll have y. So the force now, it was applied on the top. Now let us apply it here. They will just indicate the dot. That dot shows that it's a force that is applying. It's applied there. The direct force. There is a force that is applied there. Right along what? The x-axis. But now below. If it's below, now your bar will bend like this in the x-axis. But now will bend what? It will bend like this. Your bar now will bend like that. We took it. If you apply below, will bend where? Will bend like that. Are we together? Yeah, the bar will bend in that format. The bar will bend in this format, in that format. Yeah, we together will bend like let me not show like it will bend. If you use isometric, you must bend. Just you have to bend. You have to complete something like a bend there. It will bend, but you understand what I'm trying to say. Let me just say it will bend like this. You understand? Let me just use it this like this. It will bend like that. It will bend in this format. All right. So if it's bending in that format, now we know this part here will have what? Will be compressive. Our bending stress here will be compressive, but this other side there, it will be what? The bending stress there will be what? Tensile, whereby it's positive. But we have now, there's a force obvious that is applied that is causing that this one here, which is what? It's a direct stress that is acting there. Whereby what type of this? What is the type of this? It's compressive. So compressive will be what? Negative. So now since this is a direct, will be compressive. So what about now? We want the resultant. I want you to understand this is the force that will apply. We know this is what. Now this type, only this is pointing towards the section. If it's pointing towards the section, we've said that it's compressive, whereby compressive is negative. So you will have here negative force divided by what? By the area we took care. Now this bar will bend. It's like that. Will bend like this in that format we took care when we're applying there. It will bend in that format. Since it's bending, now will bend where in the x-axis. We're looking at the x-axis. So it will depend whether we are looking at which portion, the resultant, where we want the resultant. I can call this point here A. Here I can call that point A, the B. Here I can have C, D. You can have still here will be B. We'll have C, D. So will depend in this. Let's say if I find the resultant where at AP, we want the resultant there, where at AP. So AP, you see the bar will bend, will form, that part will be what, tensile throughout. This side is tensile what is positive. So that means here we'll have plus the bending stress, whereby we know the bending stress is what? The bending stress is force multiplied by eccentric, isn't it? The distance, this one, eccentric distance. All right. Multiplied by what? By y, because it's bending in the x-axis, divided by I is bending y in the x-axis. You'll have what? X. You'll have x. That is our centroid then. You'll have like that. So now you see that is how you're going to have your things. But y, we know it's what? It will be the distance from here, from the center here, going downwards here. Will be that. That is what? It's our y. We took it. Then what? I bar, we know ixx, you have seen that it will be b d cubed divided by 12. All right, will be like that. So that is what we have there so far. Remember, it's where, let me just say, it's a stress where there on the top, it's a resultant stress where AP, on AP, here on the top, this thing will bend like this. Now let's check on CT. On CT, there you see the bending here, how it is on CT. How what will be the resultant there? There's the resultant stress there on CT will be what? Remember, we start by what? It's always will be the resultant is always force, direct stress plus the bending stress. So here we have what we call, oh sorry guys, here it's tensile. Ew, it's tensile there. So I don't know why I'm doing that. Sorry guys, that is will be positive AP. So I'm sure you're so flabbergasted what I'm doing there. You're so choked. Remember here, I said like this, when it's forming like that part will be what? Tensile. Sorry about that silly mistake here. This portion here is tensile. Then this is compressive, depending there. Okay. Oh, this is the direct stress. Sorry guys, I think here is fine, it's negative. Remember that it's what? It's a you see now, even myself here, I don't know what is going to me. This is a direct. Yes, it's negative. Sorry, I don't know what is going on with me, or I'm tired. Yeah, this is, remember, this will be negative. Remember, this is simply just the direct stress. Obvious, the force is acting there towards, is fine. Okay, this that side of yours is positive, it's fine. Now let's find CT. On CT, obviously it won't change. The direct stress is simply the same thing, will be negative F divided by A. What about now the bending stress? Here is compressive in that portion. Yeah, here our bending stress will be compressive. Here between CT will be compressive, as you can see. So if since this point compressive is negative, we'll have minus now F E Y over I X. This is how you'll find your resultant at that portion. All right, I wait again. That is what is going on here. We're simply discussing about those. Here we've been looking the distance from the x-axis. This was the distance from, we're looking the x-axis, bending in the x-axis. That is what you're supposed to know so far. Now, we've seen that. Now, let's say we have now our face now. We have x-axis, we know we are here, we have y. Now, let me say now. Instant now we are no longer applying here. We are no longer applying here on the what? On the y-axis. But now instant, I apply it here on the x-axis. Our E will be this distance either way. From the center until there. Remember, it's a trick, it's a distance from the center until where it is. You see now. So if we apply it like this, we apply y on the x-axis. Our bar now will bend on the y-axis, will bend like this. If it's applied there, will bend like this. The bar will bend like this. We remember this is simply just a bar. Let me draw an isometric so that you'll understand. The bar will bend now in this format. Will bend like that. Let me just say. Will bend like this, like a curve, like something of this niche. Will bend towards that. Will bend like, yeah, you understand what I'm trying to say, isn't it? You understand what I'm trying to illustrate. The bar will bend something like, will bend in that, you see, will bend like this in the, will bend where in the y-axis, in the y, will bend like that, isn't it? The bar will bend like that. As you can see, the bar will simply bend, will form the shape of like, will bend like this instead of bending like this or like this. So no, it won't bend like that. Now it will bend like this. So if it will bend like this, so you must check here. I can call this point A, B, that edge C, D. So here I will have A, I will have here A, C, I have B, D. So the bending in this side, it's what is compressive, as you can see. The bending stress here is what is compressive, whereby compressive is negative. But this side, in this side, the bending here at that side, the bending stress at this side will be tensile, whereby tensile is positive. So I can say find the resultant. I can say find the resultant where on the, I can say find the resultant between what? A and C, like this. Between A and C. Where between A and C, like that. Find the resultant stress where A and C, even if we don't show A and C. Remember, always the resultant stress is what in the combined bar will be force or direct stress. I mean, it will be direct stress plus bending stress. So the direct stress will be what? Direct stress plus the bending stress. So we know the direct, now this force is acting like this. I want you see the arrow that I'm showing. That means it's a compressive. Compressive is what? Our bending will be negative. Now force divided by area. But what about now? We are focusing on the on this side here. As you can see here, we have what? Tensile here. So this will be what? The bending stress at that side. Since it's tensile, it's positive F E. But now, because it's bending along the y-axis, if you have a Cartesian like this, it's bending along the y-axis like this. It's bending in the y-axis. If it's bending like this, here you'll use x. You'll use x. The centroid now will be x. You no longer use like this. You no longer use this one. No, it's when it's bending along what? It's when it's bending along the x-axis. Then second moment of inertia is bending along what? The x-axis. So we have along the y. we'll have YY. It's bending along the YY now. You'll write YY. You'll have YY. And then we know that if you have bar, let me just discuss before I'm going far. Let me discuss about, okay, let's just continue. Let me see what about, sorry, the stress in this position between BC. So BC is B, DC. DC, as you can see, this is what is it is compressive. So here you will have what? A negative if you are focusing on that part. Okay, let us focus about IYY. Let's say you've given the square like this. We have depth, we have B like that. IYY will be B, isn't it? B cubed. D, you leave it because it's a Y part. Divide by 12 now. How you calculate it? This is how you calculate the moment of inertia there. Okay, that is how you calculate the moment of inertia. So that is what is our moment of inertia. But what about the x here? What is this x? This x now will be distance where? From, it will be the distance, we know this is bar. If we have bar here, we have sx. Here we know we'll have what? Yy. It would be the distance from here going this direction. It's x. Now that is x. But y is from the top going to the bottom. That is y bar. Now this will be x. So x, it's a half. It's from the middle going like till the from the center. That means it's what will be b divided by 2. That is our x there. We took it. So that is what you're supposed to know so far. For now, that is what you're supposed to know so far for this. Are we together? So some other force they can okay, before you must know that, okay, let me just say minimum stress. What is minimum stress? Minimum stress will be direct stress. Always, I'm talking this one are just direct. They will just say minimum. If you've given a minimum stress is simply the direct stress plus, or minimum will be minus, it's minimum minus the bending stress, then the resultant stress, not the resultant, I want to say the maximum. It would always be direct stress plus bending stress. You must know this. Alright, that you must know that. You must know these things, guys. So for now in this video, I think I will leave it here. So we'll put this thing into work on the next coming session. Make sure that you have subscribed, and also you can join the membership, also you can join our membership, and help us. The membership will help me, is the one that helped me to bring up these videos. You can join the membership. So yeah, so let me just remind you a little bit. Okay, let me just discuss about before. Let me just do like this. The first one, remember, the first one was placed here. Now I want you to be like this. If it's like this, the bar will bend like this. You understand? The bar will bend in this direction. Now will be simply the opposite of the other one. If you apply, the bar will try to remember this. You can draw it as isometric if you don't understand. They will give you the front view, but you can draw it like this if you want as an isometric. Maybe you might understand better using an isometric. Maybe you might understand better when you're using an isometric. So if it's applied like this bar will bend. Maybe you'll understand better when you're using an isometric. It will bend in the YY. after meaning it will bend in the YY. I'll just use something that will bend in the YY. It will bend in the YY part. We together. So it will bend like that in the YY. So yeah, that is what you're supposed to know again. And then remember where it's applying here. Remember this distance will always be as a trick. The distance from the center until where the force is applied. Even if it's applied here, will be the distance from the center until where the force is applied. Here it's our center. This line will be the distance until there. Also the distance until there. It's E. So you'll choose the E depending on whether it's bending in the x-axis or whether it's bending in the y-axis. I will do some example in the next coming session. So make sure you have subscribed me. Please subscribe to my YouTube channel and click the notification bell so that you'll be notified whenever I post a new video. Feel free to comment and like. You can share this video to your fellow classmates. Thank you for watching. See you in the next coming session.